Hey, and welcome to part 2 of everyone's favorite topic, stoichiometry, which I like to call the heart and soul of chemistry. For this one, we are going to look at changing mass to moles and moles to mass of two totally different substances. Now, first semester, we did mass to moles and moles to mass of the same substance. Like, for example, if I gave you, let's say, 18 grams of oxygen, and I said change it to moles of oxygen, or vice versa. I gave you 0.07 moles of oxygen, change it to mass of oxygen. That was the same kind of element. This time we're going to look at two totally different elements. When you do that, you basically have to use the mole ratio, which is what we did previously. So first one we're going to start off with just mass to moles. So let's look at an example of that one. There are 4 basic steps to do a mass to mole relationship. Step 1 is, just like in mole ratio, we have to write out the balanced formula. This is usually the hardest step, because if you mess up this step, the whole thing's going to be messed up. So if you can get this part done, then you get the hardest part down. Next, we have to change the mass of compound A to moles by dividing by the molar mass of compound A, because here's our end game. Basically, let's pretend I start with grams of oxygen, 18 grams of oxygen, but I want to figure out how many moles of sulfur there are. The only way to go from one type of element like oxygen to another type of element like sulfur is to first change everything to moles. So if you don't start with moles, we have to change it to moles. So in this case, look, I start with mass, whatever A is. A can be oxygen. Let's just call it oxygen. So this time I start with the mass of oxygen, but I have to change it to moles first. How? I divide by the molar mass of oxygen, or whatever A is. Once I'm done with step 2, then I'm going to change moles of compound A to moles of compound B. How? Mole ratio. This is what we did previously. So the coefficient of what I'm looking for goes on top. The coefficient of the substance I started with goes on the bottom. And then I just round my sig figs. Here's a little shortcut equation I like to use. Again, I'll give you this mass, whatever A is. Let's just pretend it's oxygen. So let's say given mass A. So I'll say 18 grams of oxygen. Well, first thing you need to do is you have to change it to moles. How? You put 1 mole of A, in this case we'll say oxygen on top, divided by the molar mass of A, which is oxygen. So this would be 32 because oxygen's O2. So it would be 18 times 1 over 32 times the mole ratio. Now remember, mole ratio, the coefficient of what I'm looking for goes on top. The coefficient of what I started with, in this case oxygen, the coefficient of the oxygen would go on the bottom. And then I just round my answers near sig figs, or the correct sig figs, and I'm done. So let's look at an example. Let's pretend I have 329 grams of zinc oxide. Okay, if 329 grams of zinc oxide is formed, that means that's the product, that's one of the products. How many moles of zinc carbonate were needed to decompose? So let's break this down. Step 1, write the balance formula. When I read this, I say, okay, how many moles of zinc carbonate were needed to decompose? This is a decomposition reaction, and I'm decomposing zinc carbonate. So I need to think, okay, when you decompose carbonates, what do I make? I make a metallic oxide plus carbon dioxide. And you know you make a metallic oxide because here's one of the products right here, the zinc oxide. So I say, all right, so it's going to be Zn is zinc, carbonate is CO3. And then I say, okay, ZnCO3, that part's done. And that will make zinc oxide, ZnO, plus 2, negative 2, plus CO2, carbon dioxide. And there it is right here. So ZnCO3 is a zinc carbonate, plus 2 on zinc, negative 2 on carbonate. They're balanced. It makes zinc oxide, plus 2 on zinc, negative 2 on oxygen. They're balanced. Plus CO2. Now I just need to put in coefficients. 1 Zn, 1 Zn. So far, so good. 1 carbon, 1 carbon. So far, so good. 3 oxygens. 1 plus 2, 3 oxygens. This one's balanced already. Easy. That's an easy one. So now, where do I go from here? Well, remember, take your given mass. I start with 329 grams of zinc oxide. So I'm first going to write 329 grams of zinc oxide. I have to change it to moles. That way I can do the mole ratio. So I'll put 1 mole of zinc oxide on top. On the bottom, I'll put the molar mass of zinc oxide, which is 81.39 grams of zinc oxide. That's the molar mass of zinc oxide. What happens is the zinc oxides, the grams, will cancel out. Because I have grams here, they'll cancel out, and that leaves me with moles. But I don't want moles of zinc oxide as my answer. I want zinc carbonate as my answer. So now I do the mole ratio. So remember, the coefficient of what I'm looking for goes on top. Since I'm looking how many moles of zinc carbonate, since I'm looking for zinc carbonate, its coefficient goes on top, which is 1, because there's no number here. The coefficient of what I started with zinc oxide, goes on the bottom, which is also 1. So this is a really easy problem. So 1 mole of zinc carbonate, 1 mole of zinc oxide. Again, these ones right here come from the coefficients. This is the mole ratio. This one right here is just part of the equation. Remember, 1 mole of anything equals molar mass. So I'm going to type in 329 grams times 1 over 81.39 times 1 over 1. Now, shortcut, what would be the big shortcut here? 329 grams divided by the molar mass, and I'll pretty much be done, because 1 over 1 is 1. 1 times anything is anything. And so I get 4.04 moles of zinc carbonate. 3 sig figs, because if you notice, there are 3 sig figs here, 4 sig figs here. The rest of these are constants, they don't count, and so the fewest number of sig figs is 3, so there's 3 there. So again, this is going from mass to moles. Step 1, write out the balanced equation. Step 2, change the grams given to you to moles. Step 3, I said step 2 for that one, yeah. Step 3, do the mole ratio. The coefficient of what you're looking for goes on top. The coefficient of what you started with goes on the bottom. And then the final step, round your answers to your sig figs and you're done.